let's explore another example of a two-sample hypothesis test based on proportions. Here's the example we looked at today. In New York City, police can stop a driver who is not wearing a seatbelt. In Boston, at the time of this study, police could only cite a driver for not wearing a seatbelt if they had been stopped for another violation. We'll highlight the important stuff as we go along here. Based on two random samples, 183 out of 220 New York drivers were wearing their seatbelt. In Boston, 68 out of 110 were wearing their seatbelt. Alright, so I got the important information here. Is there evidence to prove that New York City has more drivers who wear their seatbelt than Boston? Alright, so we're going to set this up. Now, we're trying to prove that one proportion is greater than the other. So this is going to be a 2-prop Z test. We're going to start that out immediately. So that I know it's a 2-prop Z test, okay? I know it's based on two proportions when I set up my null and my alternate. This is important. This is a mistake we're still seeing a little bit. Remember, there are no values we are throwing in here. If it's a 2-prop Z test, no values, unless you want to use 0 in the context of subtraction, which I can show you right here. Here are the ways we can approach this. We can do the proportion of, instead of lowercase, we'll go with capital. Proportion of New York drivers equals the proportion of Boston drivers. Or I could do proportion of New York drivers minus the proportion of Boston drivers. If these two values are the same, I should be getting an answer of 0. Now for my alternate, I'm trying to prove that, let's see, evidence to prove that more drivers in New York wore it. So I could do proportion of New York is greater than the proportion of Boston. We're not trying to do a specific number here. We're just trying to prove that they're either equal or they aren't equal. So now here's the other way I can set it up. I could do the proportion of New York minus proportion of Boston. Now, if the proportion of New York drivers is greater than Boston, that means this number would have to be greater than this. If your first number is greater than your second number, you're always going to get an answer greater than 0. So these are the two approaches you can take. You can do either of these. But notice that I don't have any specific values besides the number 0 in here. That's really important. Make sure that if you're doing a 2-prop Z test, no other numbers are present here. Because again, all you're trying to prove is that they are either, that they're not equal or one's greater than the other. You're not trying to prove any values specifically. All right, so let's jump to our conditions. First condition is random. Guess what? Got that checked right up here. We already checked that out. We're in good shape. So I'll put C, highlight. Make it nice and easy. I highlight it. I'm all set. It told me that there are 2 random samples. Remember, you have to prove it for both proportions or both populations in this case. Next, 10% condition. You got to do it for both. One thing I've been noticing is some people have been trying to combine the two. You don't combine them. These are 2 separate populations. You can't do that. What I can do, however, is I can look at the New York. We have 220. I think it's safe to say that 220 drivers is less than 10% of all New York City drivers. Going out on a limb here, but I think we're okay doing that. Now for Boston, we had 110 out of our total here. I think it's safe to say that 110 is less than 10% of all Boston drivers. If you've ever driven through Boston during a weekday, I think you can attest to this. There's definitely more than 110 drivers out there. As a matter of fact, you're probably more likely to make some comments at those at least 110 drivers during the course of a 10-minute drive through Boston. It can be a very fun experience. All right, let's see. Next we have large counts. All right, and here's another thing. People are combining the large counts. You can't do that. You have to approach them separately. So what I'm going to do is I'm going to label them specifically. I'll start out with New York first. NYC. All right, let's take a look. We have 183 wearing their seatbelt. 183, that is definitely greater than 10. However, I am not done. Some people said this is enough. No, it's not. We had 183 that were wearing their seatbelt. We want to figure out how many weren't wearing their seatbelt. 220 minus 183. I'm not going to necessarily do the math here because I am confident that that is greater than or equal to 10. So for New York City, I am good. For Boston, let's check it out. Let's see how good I am here. We had, let's see, I think it was 68. Yep. 68, greater than or equal to 10? Certainly is. But I am not done. Some people have been saying, okay, this is it. No, it's not. You have to also take a look at the drivers who weren't wearing their seatbelts. 110 minus 68. Is that greater than or equal to 10? I can safely say it is. I don't even need a calculator for that. And I am done with my conditions. Again, notice that I did it for both populations. You have to do that. All right, so I have done my null. I've done my alternate. I've done my conditions. Time to run my test. 2 prop z test. This is the best way of going about it. Reason is you're less likely to run into errors here. Calculator does most of the work for you. So what are we going to do here? Whoops, I didn't want to do that. Pull up the calculator. Nope, didn't want to do that. It's all right. Okay, all right. All right, give me a minute here. There we go. Okay, now we're in business. All right, notice I'm going to go to stat here. I'm going to go to tests. I'm doing a 2 prop z test here, number 6. Let's enter in what I've got. I had 183 out of 220. Okay, that's New York. Now for Boston, we had 68 out of 110. All right, now what are we trying to prove here? If I'm going with the first one, doesn't equal P2, that would be that I'm just trying to prove a difference. I am not. What I'm specifically looking to prove here is I'm trying to prove that New York has more people who wear seatbelts. So let's see. I'm trying to prove that my first proportion is greater than my second proportion. So I'm not going to go with the second option here. That would be trying to prove that my first proportion is less. I'm trying to prove that my first proportion is greater. P1 is greater than P2. So now I have the option here of calculating, and I'm going to do that. You notice I get all these numbers. All right. Wow. Let's take a look at this. I'm going to take a screenshot. Get rid of that. I don't need that anymore. Nope. Didn't want to do that either. Made it worse. That's all right. It's not the worst thing they have present here. Okay. So I want to take note of a couple of things here. I'm going to take note of my test statistics, Z. That means that difference is 4.29 standard deviations away from the mean, which my mean is 0 here. That's 4.28 standard deviations from 0. So if I had drawn this here and this is representing P of NY minus P of Boston. So represent 0 right here. Of course, we usually draw our standard deviations. That means what I got right here, that p-value is going to be way out here. That difference is going to be way out here. That's really far. So that immediately makes me think I'm probably going to be rejecting my null hypothesis. And you will notice some people said, wait, I got 9. That seems like a really off p-value. Take a look. It's to e to the -6. That means this is really low. So I'm going to do my p-value right here equals 1, 2, 3, 4, 5, 6.00009. That is incredibly low. So guess what? Let's see. Let me try this again here. With a calculator, can I do that? I'll have to figure this out at some point, but that's all right. We can still work within this. All right. So now I get to this conclusion here. My p-value is incredibly low. So I can say since my p-value is less than my significance level. Remember, our significance level was 0.05. I have enough evidence to reject the null. If the p is low, reject the ho. So what does that mean? My alternate hypothesis here was that more New York drivers wore their seatbelt than Boston. So I have enough evidence to prove this. I have enough evidence to prove more NYC drivers wear their seatbelts than Boston drivers. All right, so let's review. Again, our null hypothesis does not, null and alternate, no values involved except for 0 if I choose to go with the subtraction route like I did here. That is the only case where you include value, and that's 0. Besides that, you shouldn't have any values. I did my conditions for both. I did it for New York and Boston. I established that. I ran the 2-prop z-test on my calculator. I took note of my test statistic and my p-value. And then I wrote a nice little conclusion here at the end. This is what we'd expect when you're running a 2-sample hypothesis test based on proportions. Hopefully this helps.